Okay, so guys, listen, as a reminder, I told you guys this yesterday. Ethan, I think, was the only one that wasn't here. Okay, so guys, don't forget, we have an open note quiz tomorrow on just this section. Shh, guys, no more talking, please. Open note quiz tomorrow on just this section. I'm going to give you great notes with lots of hints as we go. This is on the quiz. This is on the quiz. There's a quiz question just like this on the quiz, except I did this. So that's tomorrow. Bring your laptops. It's on College Board. Bring your laptops. It's on College Board. And remember, you need your laptops tomorrow anyway to do your pre-bubbling or whatever session with your proctor or SAT or PSAT tomorrow. So tomorrow there'll be a different schedule. Luke and somebody else. Who else doesn't have a first period? There's somebody else that doesn't have a first period. Oh, Ethan's not here today. Okay. But this is the bell schedule for tomorrow. So second period starts at 8:12. Okay. I actually went to Mr. Henderson and I said, we need to do something for our students that don't have first period so they know when we have these activity bells. He goes, oh, okay. Okay, so I'll try to remember to tell you because I feel bad for you guys when you don't know. Okay, so laptops tomorrow, homework check while you guys are working. And remember, you're allowed to work alone or you can work with one other person. Now, it's kind of like when you really think about it, it's kind of a silly rule of me because technically once you get outside of class, you could, here's the thing. I'm going to keep the quiz open until Monday, okay, for absences and things like that. So you're going to work on the quiz, you'll put your answers in, and maybe not feel comfortable submitting it. That's totally fine. You don't need to submit it until you're ready. So, in class, working with one other person or by yourself, but you can still change your mind, go talk to the smart kid in my sixth period or whatever, your friend, and change your answers later. Okay? I mean, you don't have to submit it tomorrow, but I'm just giving you the opportunity to work with somebody in class on it. Right, that's why you grabbed them as you came in. Yes, you need this page. Yeah. Yeah. So are you going to have to do it by hand this time? Yeah, I don't know why she didn't include it in your packet. So I had to, but it was a lot of pages, so I'm kind of glad she didn't because I cut and pasted all down, okay? So anyway, let's go ahead and get started. So tomorrow's the quiz online, and then Thursday, Friday is test review days, Monday, Tuesday test. Okay, so transformations of functions is how you change it. So you have a parent function of any parent function, guys. It can be a line, a quadratic, a cubic, a square root, a log, anything. And when you apply A, H, and K to it, whatever it may be, it changes it the same way no matter what the parent function was, okay? So A, H, and K do specific things to our graph, and that's called transformations. Now, I think you guys know what a reflection is. It's like a flip over an axis. We usually see flips over x-axes, but we also have flips over the y-axis, so we're going to talk about that. Dilations, you probably called them stretches and shrinks. In geometry, they did call them dilations, okay? But it's just like a stretch or a shrink, so we'll talk about that. We don't really do rotations. That's another real geometry kind of thing. Remember, you have to turn a shape 270 degrees. It's technically a type of transformation, but we don't do them in algebra. And then translations, the most common one, which we're going to talk about right here, left, right, up, and down, right? That's just shifting the points all the same direction, same number of spaces, if you will. All right, so some of this we already know. Real quick, rigid means this shape stays exactly the same. So if I take this parent function, this absolute parent function that's a v, and I move it 3 places to the left, it's called rigid because the shape didn't change. It's exactly the same width, height, whatever, everything about it. When we get to non-rigid, that means you're going to stretch it or shrink it. It changes it's not the shape, but the size of the shape, okay? So the K on the outside, all the way to the right, not in parentheses or anything, shifts our graph up or down. And what that does to our ordered pair, think about it. it changes the y value. When we go up, you literally are just adding that k value to your y's. And if it's going down, you're subtracting the k value from your y's. Okay, pretty simple. This is tricky, not probably anymore for you, but back when you learned it the first few times, oops, sorry, not those two, these two. Ugh, those two are tricky here. When you have the minus in the parentheses or the plus in the parentheses, that's our h value, okay? That is changing your left or right movement, and it's opposite. So if you remember, having a minus in there takes your graph to the right. So that's going to be plus h, okay? And then nothing happens to your y value. And then when you see a plus, it takes you to the left. So that's a subtraction by h. Nothing happens to your y. So far, pretty common sense, right? If you go up or down, it's going to change the y value of all your ordered pairs. And if you go left or right, it's going to change the x value of your ordered pair. Just be careful with this, and we'll see this in an example again in a second. This one we really don't talk about a whole lot, but what the absolute value of f of x says, it really just takes all of your negative y values and makes them positive across the x-axis. And we'll see that also again in a minute. And I'm going to go deeper into that concept right here, which is when you reflect across one of the axes. So if you go across, take any of your points across the x-axis or take any of your points across the y-axis, think about which variable that affects, okay? So when you see a negative right after the equal sign, that's reflecting over the x-axis, which should be pretty familiar. It's the most common one. Think about a parabola, like a smiling, happy parabola is positive, and then when it's negative, it flips over the x-axis. But what does that change? Which part of your ordered pair is affected when you go over the x-axis? The y, okay? The y value is affected. Remember, y value, just like up here is up and down, it affects your y value. Going above or below the x-axis is vertical movement. So that affects the y value. Just like if we go across the x-axis, that's going to change the x value. It's left to right movement, okay? And this is one we don't see as much. Okay, you might have touched on it in Algebra 2. I don't even know if I did very much. But when you see a negative inside the parentheses, that is telling you you're flipping across the y-axis. So don't make it so simple in your brain and say, oh, when the y is negative, I flip over the y-axis. When the x is negative, I flip over the x-axis. That's not what it's saying, right? Think about when you change the sign of an x value, it goes left or right, okay? And you change y value up and down. And we'll see that in action in a minute. So those are our rigid transformations. Non-rigids are stretches and shrinks. Now these first two, I'm sure you will be familiar with once I go over them. And I think she means to I think this is supposed to be an A here and an A here. So just make those A's. It's not a big deal. You'll probably never look back at this page. But vertical. So we've called them stretches and shrinks. We're throwing in dilation, compression. You're going to see all these words kind of mixed in together. Even this, though this says vertical compression, it could also be vertical dilation, okay? Dilation is kind of like an umbrella term for like a stretch or a shrink. So there's lots of different ways. You'll see it all. But what we look at is the absolute value of the A value. So the number that comes right after the equal sign stretches or shrinks your graph vertically. Vertically. Remember, vertical changes affect the Y value. Whatever A is, we multiply it to the Y. Whether the A value is greater than 1 or between 0 and 1, what does that mean? Greater than 1 would be like 2 in front. Y equals 2x squared. Or between 0 and 1, still positive, like 1/2, okay? That's why this absolute value is here. And I'll talk about that when we get to an example in a second. Why is the absolute value there? These are the new ones. These are the ones that we have to be careful with. These are the trickiest ones. And you'll see, we're going to do 2 examples with these. when you see a number in the parentheses, like separated in the parentheses, just like we saw the negative separated from everything else in the parentheses, you know that that's going to change the x value, okay? So like I said up here, in parentheses, they're like secluded by themselves. That changed the sign of the x value. If you see a number secluded by themselves in the parentheses with the x, that is going to be a horizontal compression dilation factor, and it changes the x value. But here's what's sorry, I forgot to write this. Whether it's greater than 1 or less than 1, it doesn't matter. Whatever that a value is, you multiply it by the y value. And then for these guys, you actually divide the x value by b. Okay, and I'll show you this all in a moment. But just know that these are the ones that are newest for us. I didn't cover them in my Algebra 2 classes. Okay, but we will see them definitely now. Okay, now I'm going to take all of this and show you examples of it on the next page. So, there you are. My pens bleed through, so I try to put a piece of paper down. All right, so we're not going to do any graphing. So just so you know, you can ignore the graph. Same in the homework. Let's look at these and talk about what transformations are occurring, and then I'm going to show you what happens with the ordered pair. It's actually really cool. So let's just go through this. After the equal sign, there's a negative. Okay, it's not secluded in the parentheses. This is a reflection, and you can do some abbreviation. Reflection over, but you have to say which axis. Okay, because now we have two. It could be x or y. When you see it right after the equal sign, it's a reflect over which one? X. That's right. And it helps if you remember, I mean, I know in Algebra 2 especially, we do a ton of stuff with parabolas. And I always talk about happy parabolas smile, A is positive, right? Negative people frown. So when a parabola has a negative in front, it goes down. That's just flipping over the x-axis. So I always remember that to help me memorize. Okay, that's flipping over the x-axis. Okay, the -2 in parentheses, what does that do? Moves us what direction? Right, and you don't have to write it all out. I mean, that's as good as what I would write, okay? It's technically a translation shifted to the right 2 units or something. And then the +4, right, is up 4, okay? Let's talk about how that changes all the points of the graph, even though we're not graphing it, okay? So going right or left, of course, affects the x value, right? That's going to take all of our x values right. So going to the right, that would be +2, okay? Going up 4 is going to take my y values up 4, but also reflecting over the x-axis is a change in the sign of the y. So we change the sign of the y and then go up 4. And we're not graphing, but let me just prove to you, I told you I would. Like if I pick a point right here, that point is +3, 2. If I change the sign of the y value, in other words, now I make it 3, -2, where is that? Okay, oh, she's right. When I change the sign of the y value, I flip over the x-axis. So a x-axis flip affects the y value. You get that? Okay. So another one. Okay. That number at the front of the parentheses right after the equal sign is a stretch by 2, you might have said, but we need to now insert the vertical. Okay. Vertical, stretch, dilation, whatever you want to write, understand they're all interchangeable. You have to put vertical. That's what I was just saying. It's going to affect the y value. Vertical affects the y value. If you just put stretch, I wouldn't know if you meant vertical or horizontal. Okay? The +3, remember the tricky thing I was saying, it's always opposite. That's left 3. And then -4 is down 4. So take a quick look. I have one thing affecting the x value, that's left or right. The other two affect the y value. So my ordered pair would be x minus 3, take all my points, left 3. And then my y value, it's a stretch by 2. So I multiply my y values by 2, and down 4 would be minus 4. And this that I'm writing in red is new to me, doing it this way. It is going to make graphing so much easier. You're going to love it. You'll see in just a second. All right, I'm going to skip to D, and I'm going to save the hardest one for last. So let's go through all of the different transformations. I see a negative after the equal sign. I know that that's going to reflect over which axis? X again, yep. I see a 1/2. That can be, we have to say vertical, okay? Vertical, we can say shrink, we can say dilation. You don't have to write both. I'm just trying to give you every possible word you could see. What am I going to write here? What is that number? Careful. 0.5, negative 0.5. It would be wrong if you wrote negative in front. You could write 0.5. But the point is it has to be positive, okay? Here's the thing. The negative is one transformation, 1/2 is a separate one. I know we read it as negative 1/2, but they actually are two separate transformations. Remember I said I would talk about why the absolute value is there? When you stretch or shrink, it's always by a positive number. You'll never put a negative number in front of a stretch or shrink, okay? If there's a negative, it is a separate transformation, a reflection, okay? And then minus 3 is right 3, and then the plus 2 is up 2, okay? So again, there's absolutely nothing except the right 3 that changes the x. Y gets a lot of things going on, okay? So that would be x plus 3 to take all my points to the right. Reflect, that's going to be a negative. The vertical shrink is 1/2, so it's negative 1/2 times the y, and then up 2. Okay. This one can give us headaches. This one, pay attention, and then we're not doing example 2, but I'll give us another one of these to practice down here. There's one of these for sure like this on the quiz, so you want to understand this one. So whenever there's something happens in the parentheses, you got to be on your toes, okay? Because there's an extra little weird thing in there. First thing I'm going to do is I'm going to put this, what's in parentheses, in the right order. Not that, and I shouldn't even say the right order. There's no wrong order with that. That is the order that typically you would write it in, but I'm going to make it more familiar to me. So I'm going to put the x first, and right now the x is negative, right? So I didn't do anything fancy. I literally just had them switch places in line. They're still who they were when they were in a different part of the line. The x is negative, the 2 is positive. I just had them switch places, okay? This is saying, oh, something's happening inside the parentheses. She told me to be ready for this. Okay. So a negative inside means you're going to be flipping over the what? The y-axis, okay? But that's not the hard part. No, I don't think anyone's really confused about that. But you have to have, this is your goal, whenever you have anything going on in the parentheses, you have to have just an x here. I don't care what happens over here, but it has to be just x, not a negative in front of it, not a number or anything. So watch what you do. I'm going to factor out the negative, okay? So I'm going to take a negative out of the parentheses. That's going to change my x to positive, and it's going to change my positive 2 to negative 2. Okay? So I just did the reverse of the distributive property. Negative times x is negative x. Negative times negative is positive. But watch this last thing, because if I leave it just like this, I just changed the problem completely. This is now saying it's a y-axis, or an x-axis flip, right? But it's not. You really have to keep what we just did in a new set of parentheses, or you can make it brackets. Because what we just did was we just changed the parentheses. This is everything that's in my red parentheses came from inside my green parentheses. So it's all still X stuff happening. I can't change the problem and make it now a Y-axis flip just because I didn't use the right symbols. So what this is saying is still an X-axis flip. Y-axis flip. So reflect over Y-axis. And you might be saying, I already understood that. Why do I have to do that step? It's because if you didn't do that step, what direction do you think the 2, you would think maybe by accident that the 2 goes to the left. It doesn't. It goes to the right when it's written correctly. That's tricky, okay? And then down 1. So the -1 was just kind of patiently waiting the whole time. We didn't do anything with it. Okay, so I'm going to do another one like that in just a second. Now, when we reflect over the y-axis, that is going to make the sign of our x value change. Just like with the x-axis flip changes the sign of the y value. Okay, and then right 2 would be +2. And then we're just doing down 1 on the y. Okay, those are tricky. Let me make up another one for us. Use the space down here. What should stand out to you is that x is not up against the parentheses by itself. That's what has to happen, okay? So I say, okay, I can factor a 3 out of both of those. So factor out a 3. That leaves me with x plus 2. We didn't have any problem with signs. Here it was just the 3 that was in the way. If it was a -3, I'd factor out a -3. But don't forget, all of that is still in parentheses. All of that is still in parentheses. And I think I don't think I should have kept that 3 in there. I think that 3 should have been there. Sorry. It doesn't really matter. You're really just doing this to make it right. These parentheses, or you might see brackets, are saying all of this is still happening to the x. It's not a 3 out in front like a vertical stretch by 3. This is still a horizontal stretch by 3. Horizontal. Okay? So horizontal, that's why we have to write vertical or horizontal, because there's 2 different ones. And you could say stretch, you could say dilation. And again, if you hadn't factored that 3 out, you might be thinking you're doing something with the number 6. We're not doing anything with the number 6. We are going left 2, right? That's why you have to write it with the x right against parentheses. Okay? And so what does our ordered pair look like? If I'm doing a horizontal stretch or shrink, that affects the number left, right, horizontal, horizon. That affects the x. And left 2 also affects the x. Nothing special happening with the y in that problem. Say it again. Because it's inside with the x. It is divide by 3. It is divide by 3. When you divide out the 3, sorry, I'm so sorry. Your b value is 3. Fix this, guys. Oh my God, I taught it wrong first period. Your b value is 3. Thank you, Lexi. So we don't actually multiply by the 3. We divide by the 3. I am so sorry. So there's the b. We divided it out. But since this is our b value, just like in letter D, a was our 1/2. We multiply. B, we divide by. So if you look back at your first page, Whatever b is, you divide by it. So it looks like multiplication in the problem, but when you actually do the math, you would divide by the 3. Okay? We didn't have a value in C. There was only a negative. It just flipped it. So if there was a number there, like a 2, yeah, you would divide by 2. But in C, we didn't have a number in front of the x, except for 1. Okay, you could call it dividing by 1 if you wanted to, but that's not going to change it. Okay? All right. Let's whip through this next one, because this is so easy. I feel like it's almost a little like, really, a little repetitive and basic. So what we have here, what we're doing here is, it's 3 parts, A, B, C. So A is to, in the grid at the right, graph f of x. Here's f of x down here. These are just points. So take a quick minute and graph these points right on this axis, okay? And we're going to connect them with little, it's not going to make anything that you recognize. It's just a bunch of points. It's going to look almost like a weird M, not on purpose. It's not like you could like identify it as that or anything. These are just random points, okay? That's the whole point of it, right? So we talked about you could do this to any parent function, but you could make these transformations to any graph in the world. In fact, just something crazy looking like this. So what are the transformations? Let's just talk about them real quick. We have a reflect over the x-axis, right? That negative in front is a reflection over the x-axis. The 2 is a vertical dilation or stretch by 2, not negative 2. Right 3, up 4. That's everything going on in our new h of ax function. And here's what I really, really love about these ordered pairs we're coming up with. It's going to make, we're going to do all of those things to that weird graph. But it's super simple when you just come up with the ordered pair like we just did. So the only thing affecting the x value is right or left here, right? That's the only thing that's in the parentheses. So we're going to take all of our x values and add 3. And then our y values, printed on letterhead. Can you come talk to me at lunch? I'm so sorry. I'm like recording a lesson and everything. Thank you so much. Okay. So we're going to reflect over the x-axis. That's going to change the y value. Vertically, that's going to change the y value up 4. So it's a negative 2 times y. There's my reflection. There's my stretch. And then up 4, right? Then I'm going to go down here, part C, and do the math, okay? Guys, let's not make this too cumbersome. For our x-coordinates of our current graph, what are we going to do to all of them? Add 3. So it's negative 4 plus 3, negative 2 plus 3, and so on. Just adding. And our y-coordinates, we're going to multiply by negative 2 and add 4. So it's negative 2 times negative 2 plus 4, which would be 8. Negative 2 times 3 plus 4. The whole way down. Think about all that we just did with that really simple fast math. We are reflecting, we're stretching, we move right up 4, and now if you just graph these points, you'll have your new graph. Now if you're not using 2 colors, that's fine. Maybe just use X's on your second graph, just so you can see where the points are. And graph them. That's you. Not something you could have predicted, right? But this made it really, really simple. Good? Easy? We are almost done. So, your last little page here, I just need so much paper. I'll steal from this class. Okay, so this last example, they give you a graph. Now, I'm not going to do this whole thing, because this is how this question will come up on your homework, on your quiz. Given a graph, given some transformations, pick, multiple choice, pick A, B, C, or D, which one matches it. So we can look at that and say, okay, that's left 2, down 3, right? There's no stretching or shrinking. There's no flipping. It's a really basic movement. So here's all you would want to do. Pick a point. Pick one single point on your graph. I don't care which one. Maybe this one, okay? And move it left 2, down 3. So left 2, down 1, 2, 3, right? I should have, in one of those 4, I should have a graph that has a point at 2, negative 3. I'm looking at this right. I'm looking at it right. Left 2, down 1, 2, 3. Yep. So when I move this point left 2, down 3, all the points are going to follow that same pattern. So don't feel like you have to graph it all. You're going to go through your choices, find the one that has a point there. Now, is there a chance that there's 2 graphs with a point at that point? Yes. Usually no. So if there was 2 of them, well, then just pick another point and narrow it down to those 2. Do we get that? Understand? Easy, right? Okay, so don't finish that. You don't need to graph all those points. I know you guys know how to move a point left 2, down 3, left 2, down 3, left 2, down 3, follow them. Okay? All right, this is another one. So easy, but you could think it was hard. There's one of these exactly like this on the quiz. There's actually 2 questions that come from this. They're both like freebies. 8 questions, 2 of them come from right here. Okay? Here's f of x. We're going to write the equation for the graph of the function k that is a multiplicative transformation by a factor of 3. This is the same exact thing as if I called it a vertical dilation or stretch. You might see any of those words. All you have to do is multiply by 3. The whole thing. We don't need to factor it. I don't need to see what the graph looks like. It's literally, you're going to get a problem just like this, and you will, and it's multiple choice, multiply everybody by 3, and then that would be your new equation, what they call it, k of x. Yeah. Okay, another way I could ask this question, given f of x, which equation shows a translation down to? All you would have to do is subtract 2 from 8. So it would be like 2x squared plus 5x plus 6. That would be the answer. It's that simple. You wouldn't get a question like that was left or right, because we don't have this written in what's called vertex form with the parentheses. Don't worry about that. But it would just be an up or a down, because it always happens to the constant, the number that doesn't have a letter, the number at the very end if you're in standard form. Okay, so you're going to have a second question that comes from something like this where it says up or down a certain number, and you literally just add or subtract to the constant. Okay, there's 2 questions on your quiz. And I told you one right there. There's 3 questions. This is our last example. This is the hardest one. And I'm going to do this problem with you. And then if you want me to do another one right before the quiz tomorrow, I will. You'll still have plenty of time to work on the quiz. So just remember that, okay? So look at what this is saying. So this table of values, so there's one just like this on the quiz though. So I would just write really good notes with me here. So you're going to be given a table of values, okay? So this represents function f. This is f of x. We want to write a new one called g of x. And we're going to do these transformations to it. Now, we only want to know what happens with 1 point, okay? So when we do g, what we're trying to find is what is g of negative 6. So that's what we start with in this problem, okay? So to find g of negative 6, what you're going to do, and I'm just going to kind of use some of this notation. We're not doing anything with the a or the f, but we are going to do something inside here plus c, okay? So I'm taking my x value, so remember f of x, and because it's a horizontal dilation by factor of 3, instead of multiplying it by 3, I divide it by 3. Remember, thanks to Lexi, horizontal dilation, we divide, okay? So I just take that x value and I divide. Now you all know what we're going to get there. We're going to get a answer of negative 2, right? Negative 6 divided by negative 3 is negative 2, right? Let's go on to the next step, a vertical dilation. Vertical, okay, that goes on the outside. I'm going to replace a with that. And here, it's written here. I'm just filling in what they're giving us. Now here, right here, is the place where students mess up. Right here. So be super, super careful. F of negative 2. Think about what that notation means. F of negative 2, it's asking what is y when x is negative 2. That's what that's asking. We don't actually multiply negative 2 by 2. We go back to the chart. I'm being obnoxious for a reason. When x is negative 2, y is 12. So what we actually have here is 2 times 12, which you could have already made it to 24. And then a vertical, that's up 5. If it said minus 5, we would subtract 5. It just says vertical translation by 5, so that's up 5. And our final answer would be 2 times 12 is 24, plus 5 is 29. The one on your quiz is almost exactly like this, different numbers, but you can see where that confusion could come in right here, okay? So if you remind me before the quiz, I'll use the same problem and just do another one from here and follow the same steps so we can practice again, okay? But let's do it tomorrow, not today, all right? So that's it for the notes. You also now have your homework page. It's very short. I did more in the notes than there is in the homework I wanted to do lots more with you. You have lots of good answers and information. Practice a little bit, ask questions, bring both tomorrow. Okay? So one little thing, I wrote for number 12, do all parts, and then I said except part A. Cut part A. Okay? And I'll put the key up. You guys have some time to work. Not a ton of time. You have about 5 minutes. You could probably get the whole first page done. And the back is really easy too. So I didn't give you too tough of it.